Hello there, Charger Deers. It's Mrs. Boyd coming at you with the Pythagorean Theorem. It's going to be amazing. Name of the game today is going to be this baby right here. The triangle ABC is a right triangle with legs A and B and hypotenuse C, just like we have here. Leg is A, little b are the legs. It doesn't matter. Short leg, long leg, doesn't matter. Just they're not the hypotenuse. C is the hypotenuse, always and forever. Then we know that the sum of the squares of A and B, A squared plus B squared, is equivalent to C squared. So let's use that little tidbit of info to solve some problems. We can use this theorem to solve for a leg or a hypotenuse. Does not matter. We've got, as long as we know the hypotenuse, the right triangle half square here is always pointing at the hypotenuse. So we've got 3 and 6 are A and B. Doesn't matter which one they are. 3 squared plus 6 squared is C squared. Well, 3 squared is 9 plus 6 squared is 36 is equal to C squared. Well, I can combine 9 and 36 and get 45 is C squared. If I want to get rid of this square, I have to take the square root of both sides, and that gives me C is equal to the square root of 45. You could simplify this. I don't care about it that much. Square root of 45 is sufficient for me. Now we can find a leg that's not the hypotenuse. So our hypotenuse is square root of 43. So we have 5 squared. Well, let's not do that. Let's do A squared plus 5 squared is equivalent to the square root of 43 squared. Well, A squared stays A squared. 5 squared is 25. And the square root, or the square of something under the square root, cancels everything out, and we're only left with what's underneath. So that's 43. Now I can subtract 25 from each side. And we get A squared is 18. To get rid of the square, take the square root, and A is the square root of 18. Phenomenal. Now, same thing, but now we don't know this B is random B, another leg. We know the hypotenuse is what's 12. So we have 10 squared plus B squared is 12 squared. So that's 100 plus B squared is 144. Subtract 100 from each side. We get B squared is 44. Square root all the things, and we get B is equal to the square root of 44. Hot dang. All right, let's do some more. They look a little more sinister because they've got some square roots in them, but it's not to make you afraid. It's going to be totally fine. Our hypotenuse is here at C. So we know we can do 2 square root of 3 squared plus square root of 5 squared equals C squared. Well, 2 square root of 3, we're going to kind of distribute this square. 2 squared is going to be 4. The square root of 3 squared, like I said above, when you have a square root and a square together, they just disappear. So that makes 3. Plus square root of 5 squared is just 5. And that equals C squared. 4 times 3 is 12. Plus 5 is C squared. That means C squared is 17. Take the square root of both sides, and C is the square root of 17. Let's do another one. Hypotenuse is 5 across from the right angle. That means we've got A squared plus the square root of 3 squared is equal to 5 squared. A squared stays plus 3, and that equals 25. We subtract 3 and get A squared equals 22. square root, and a is the square root of 22. Last but not least, this will make everybody happy. We're using some decimals. Our hypotenuse is 12.5. So we do 7.5 squared plus b squared is equal to 12.5 squared. Well, 7.5 squared is 56.25 plus b squared. 12.5 squared is 156.25. We can subtract 56.25 from both sides. And we get b squared equals 100. When we square root, we get b is 10. That's fancy when we just get a whole number like that. The next part, the Pythagorean triplets. I don't care about that. There's enough things for you to memorize in geometry, and I feel like that's just one more that we don't have to have. All right, we can use this theorem to determine whether a triangle is a right triangle. The Pythagorean theorem is what we're talking about. We want to determine if the given side lengths form a right triangle. Well, we know that the hypotenuse will always be the longest. Hypotenuse is always the longest side. So whatever our biggest number is, that's going to be our hypotenuse. So we want to see if 21 squared plus 72 squared could possibly equal 75 squared. Well, 21 squared is 441. 72 squared is 5184. And 75 squared is 5625. I did these all just with my calculator. You can add the things on the left, and we get 5625 equals 5625. The answer is yes, this could be a right triangle because the sides are the correct length. Let's do that again. 11 is our biggest side, so it will be our hypotenuse. We've got 4 squared plus 7 squared equals 11 squared. Do not say 4 plus 7 equals 11 because that's not right. We've got 16 plus 49 might equal 121. Well, 16 and 49 is 65. And that, in fact, does not equal 121. So the answer here is no. It is not possible for these to be a right triangle. 24 is the longest side here, so that's our C. We'll have 3 squared plus the square root of 10 squared plus 24 squared. Oh, nope, that should be equals 24 squared. 3 squared is 9 plus, I don't know what I've written up here. Ooh. Oh, and now I can't get it to disappear. Oh, well, don't know what that is. Don't look at that. Square root of 10 squared is just 10. 24 squared is 576. Well, 9 and 10 is 19, and that, in fact, does not equal 576. So that's a no. Last but not least, so if you want to find out which one of these is bigger, 2 square root of 10 or 11, 2 squared is 4, right? So we can make that 4 times 10 under the square root. Well, that's the square root of 40. 11 squared is 121. That's the square root of 121. So 11 is our biggest number. We can take 9 squared plus 2 square root of 10 squared and make that equal to 120. Whoop, nope, 11 squared. That's 81 plus 2 squared is 4 times 10 equals 121. Well, that's 81 plus 40 equals 121. Or 121 equals 121, And that is a yes. That could be a right triangle. Just a few more things and we're done for the day. Televisions are measured by the screen's diagonal length. If the diagonal of this TV is 52 inches, let's draw. If this is 52 and the width is 40 inches, what is the height? We're going to call that A, round to the nearest tenth. All right, so we do A squared plus 40 squared. This is the right angle, so this is the hypotenuse, equals 52 squared. Well, that's A squared plus 1600 equals 2704. We can subtract 1600 from each side. And that's A squared is 1104. Do the square root of each side and get A is the square root of 1104. You put that baby in your calculator and you round to the nearest tenth. You should get about 33.2 inches. Super duper. Last little bit here. Pythagorean Inequality Theorem. If A squared plus B squared is greater than C squared, the triangle is acute. Acute meaning the angles are all less than 90. If A squared plus B squared is less than C squared, the triangle is, you guessed it, obtuse, where it has at least one angle that is more than 90. So determine whether the triangle is acute or obtuse. So we don't know if, there's no hypotenuse. All the side lengths are the same in this first triangle. So we can say 3 squared plus 3 squared is something to 3 squared. Well, that's 9 plus 9 is something to 9. That's 18 is something to 9. Well, 18 is greater than 9. So that means this is an acute triangle. We just pick two sides, add them together, especially in this case. Again, we'll use the longest side for our C part of the equation. 5 squared plus 5 squared is something to 8 squared. That's 25, and 25 is something to 64. Well, 50 is less than 64. So this will give us an obtuse triangle. It's more than 90. Last one, sides are 2, 3, and 4. Biggest one's 4, so we'll make that C. We want to know what 2 squared plus 3 squared is to 4 squared. Well, that's 4 plus 9, and it's something to 16. 13 is less than 16, which makes this an obtuse triangle as well. All right, my children, I hope this makes all sorts of sense to you. If you don't, reach out, let me know, and I'll look forward to seeing you soon.